Data Skeptic is the official podcast of dataskeptic.com, bringing you stories, interviews, and mini episodes on topics in data science, machine learning, statistics, and artificial intelligence.
Ruggiero Cavallo has a PhD in computer science from Harvard University. He was a postdoctoral researcher at the University of Pennsylvania and then at Yahoo Labs' Microeconomics and Social Systems Research Group. He then went on to work as an associate researcher and founding member of the Microsoft Research Lab in New York. Ruggiero is currently a senior research scientist at Yahoo Labs in New York, where he works on ideas that lie at the intersection of computer science, game theory, and microeconomics, with a focus on mechanism design and its applications to multi-agent systems, electronic commerce, and artificial intelligence. In particular, he's interested in understanding social welfare, fairness, and how human self-interest and computational limitations influence decision-making processes. When Ruggiero is not working on Yahoo's pricing and marketplaces team, he's a musician, guitar player, and songwriter. He lives with his wife and two small children in Brooklyn. Ruggiero, welcome to Data Skeptic.
It's good to be with you.
So we're going to talk about your work in ad auction marketplaces today. And I know pretty much everyone listening will, of course, be familiar with the concept of internet advertising, but maybe not some of the particulars or even that it's auction-based. So I thought maybe to begin with, could you talk about the general mechanisms for how ads go from our advertisers to our browsers?
Sure. So there are a few different kinds of ads that you might see on the web. Maybe the most commonly known kind or the oldest kind are those pictures, banner ads that you see maybe at the top of the page or on the side. If you're just browsing some random page or looking at your email, that still accounts for a large portion of internet revenue, but it's kind of shrinking. And the bigger story has been things that are a little bit more specialized, mainly ads that are shown alongside search results. The big search companies, Google, Yahoo, Microsoft with their Bing search platform, they all show ads that will appear at the top or on the side and maybe on the bottom when you do a search. Not every search, some search queries that you might put in just don't go along with anything that anybody would want to sell you. But if you search for something like, lawyer or laptop, you're pretty much guaranteed to see some ads that appear at the top. And those kinds of ads are all sold with auctions.
So I imagine if I went and participated in that auction, I ought to be able to bid on a keyword like data science podcasts, and I would rank my website rather highly, I would hope anyway. But if I went and bid on lawyers and laptops, not necessarily the most relevant ad, what would prevent me from placing highly in that situation?
Probably, it works differently depending on the search engine. It's not the same everywhere, but the first thing that might happen is there might be some filters, some basic filters that the search engine might put on to say, unless there's a certain basic level of relevance, then we're just not going to show a given ad for a given query because we don't want to make the user have to endure a bad experience where we show them something that's clearly not what they were looking for. But so once it passes by that, then assuming you're relevant enough, then you're going to be competing with other advertisers who also want to have their ads shown for that query. And basically, the first approximation, whoever bids the highest is going to get their ads shown at the top. But there are other things that come into play. So for instance, if you have an ad that is really attractive, really appealing to users, and it seems like they want to click on it a lot, that's how they show us that they're interested in your ad, then maybe a bid that's not quite the highest would still be able to win and get shown at the top. So it's usually a combination of your bid, what you're willing to pay to have your ad clicked on, and also some other factor that's a representation of your quality or match with the user.
So I think people have, if not an understanding of online auctions, at least a familiarity with the idea of, an in-person auction or maybe eBay. And maybe the analogs between digital and offline advertising are important. If so, we can go into them. But what I think is a little bit more curious and definitely relevant for your work is that the underlying mechanism is different from what people might expect. It's not that people show up and the highest bidder wins exactly, or I suppose maybe they do, but that's not exactly how they end up paying. Can you get into some of the specifics on second price auctions?
Yeah, sure. So for these, sponsored search auctions, for these ads that are appearing alongside search results, as we've been talking about, one thing that's different from eBay here is that many things are being sold at the same time, right? So it might be that there are 2 or 3 or maybe even 8 or 9 different ad positions that are being sold in a single auction. The winner of the auction is going to be the one who's shown in the most desirable spot, which is usually the top of the page. And then the guy who comes in second might be right below him and so on. And then, at some point you'll fill up the top of the page, whatever space is being allocated to ads at the top. And then maybe you'll move over to the side. And then if that gets all filled up, maybe the search engine will even decide to show some underneath at the bottom. But the point is there are a lot of things being sold at one time, and all of this takes place in a single unified auction rather than kind of a separate auction for each slot.
In talking about why I would pay the second price, could you explore a little bit about why the platform owners have picked that as a mechanism?
Sure, right. Yeah, so maybe a little bit of history here first. So it wasn't always that way. So I think, originally when the idea of showing ads alongside search results first started, the company that was first doing this, they actually said, well, let's just charge each advertiser their bid. If they say they're willing to pay $1 for a click, if somebody clicks on them, let's just charge them $1.
Makes sense.
And that has some problems because if you were bidding in this auction, you'd probably say, look, I know that what I pay is highly sensitive to what I'm reporting that I'm willing to pay, my bid. So I should try to find the minimum bid that's going to allow me to win. So if my nearest competitor is only bidding 50 cents, then anything I'm bidding above 50 cents, it doesn't get me anything more. If I bid 51 cents, I'm still winning the auction, but anything I bid above that is just more money that I'm volunteering to give the auction. So that's bad. So you have advertisers who, if they're smart about it, they're searching around to find the minimum bid that they can submit in order to win. And if you have everybody doing this at the same time, then what happens is you get an unstable situation where prices they go down for a while, or the bids go down for a while until you realize, wait a second, now I'm not winning at all. I better pop my bid back up. And then after you win for a while, you start to think, okay, I should start lowering my bid again until I make sure that I'm finding that minimum bid that I need to in order to win. So it's an unstable situation that involves a lot of work for the advertisers because they constantly have to be thinking about what their competitors are doing and finding their optimal bid. The idea, and these are old ideas they didn't come about just because of sponsored search, but they go back to the 1960s with work from economists like William Vickery and so on. But if you replace that first price auction with a second price auction, where instead of paying your bid, you pay the minimum bid that you would have had to bid in order to win, and that would just be the second highest bid if you're just bidding on one thing, if there's just one slot, say, in the auction. Conditional on winning the auction, the price that I pay is completely independent of what my bid is. There's no incentive for me to search out that minimum bid required to win. I just have to decide, is it worth it for me to win this auction? Mm-hmm. And if it is, then I'm happy with winning it. I'm happy with my bid. So this second price auction, in the case of a single good, has this really nice property that your optimal strategy is to just bid your true value, your true maximum willingness to pay for a click.
That is the proven Equilibria strategy, is it not?
Yeah, it's actually even stronger than an equilibrium because even if the other bidders are doing something crazy, like they don't realize that the auction has this property and they're all, overbidding, they're multiplying their true value by 2 or, multiplying it by 1/2 and submitting something that's, nowhere near the truthful bid, it's always your best strategy. So it's actually a dominant strategy. That's what they call it, to submit your true value as your bid. It's all in the world where there's only one thing being sold. The situation changes dramatically when we get to, a world with multiple different ad slots, and I'm sure we'll get to that.
Yeah. I think it's strong support for generalized second price mechanisms is that we've seen most of the major players in online ads, at least in pay-per-click, either adopted or migrated to that sort of approach. But that all happened a decade or more ago. A lot's changed in the ad world since. Could you explore maybe some of the evolutions that could cause us to rethink this approach?
Maybe as a little bit of a prelude to that, let me try to finish this part of the story about the incentives of a second price auction and how it was kind of ported to this sponsored search world where we're selling multiple things at once. So, I described that second price auction as having this great property of, truthful bidding being your optimal strategy. But when you're selling more than one thing, as in the case of sponsored search, where let's just say you have 3 ad positions that you want to sell at one time, now what's the second price? There's the top guy who's the top bidder is going to get the first slot, and maybe you could charge him the second highest bid. That would be his price. All right. Now, what do you charge the second guy? He's not the highest bidder, but he's still winning something. What should he have to pay? The first people who started setting up a second price style auction, they were at Google, I think in 2002 or sometime in the early 2000s. And the way they chose to generalize this, this second price single item auction was to say, well, let's just charge every bidder the bid of the guy who won the slot below him. So if you win the first slot, then you pay the bid of the guy in the second slot. If you win the second slot, you pay the bid of the guy in the third slot, and so on. And they consider this kind of a generalization of the second price auction, and it is. So it's called GSP, or the Generalized Second Price Auction. However, this generalization does not actually retain that property of always being an optimal strategy to bid your true bid. In fact, the guy in the second slot, he could be paying something much lower than the guy in the first slot for a click, right? So let's just say that the the first two bids were really high. There were two really high bids, $10 per click. And then there was a bid of, 10 cents per click. If you get that top slot, you're going to have to pay $10 for every click. If you get the second slot, since the bid of the guy below you is only 10 cents, you're only going to have to pay 10 cents per click. So even if the second slot doesn't get nearly as many clicks, and it's really not as great a position, the clicks there are basically free. So you might want to say, I want to make sure I bid under that top guy in order to get that cheaper position in the second slot. So it doesn't actually have this truthful property. And if you really want to generalize the second price auction from the single item world to this multiple item world, the generalization of that is called the Vickrey-Clark-Groves mechanism. It doesn't have this very simple form of just looking at the bid of somebody below you. It's a more complicated pricing form that looks at the bids of all of the advertisers and comes up with your price. But there is a way to make the whole thing truthful so that everybody's best strategy is to be truthful, but this isn't it.
I guess we could go into some of those details, but I'll maybe refer people to your paper and some of the references because it gets into some of the technical specifications, but I think you gave a really good high-level description of it. So that system has worked for a while. At least the owners of the ad platform seem to like it, but ads have changed in the last decade, have they not?
Yes, right. So ads have changed a lot. So, nonetheless, despite GSP not having the truthfulness property, it actually does have a truthful equilibrium. So there are kind of reasons and maybe, also empirical reasons based on 10 years or more of experience with it to say that this GSP version is pretty good, or at least it seems to have some properties that work well, good revenue properties and also good properties in terms of stability and making sure that good ads end up getting shown to the user. So it's been successful for a while, but the world that it was kind of invented to match has changed a lot. So originally, what did sponsored search ads look like? They were actually all the same. They were 3 lines each. The top line would be some kind of title for your ad, the name of your company or something. The second line would be a URL. If you click on my ad, what page on the web are we going to? And then there would be a final third line that's a short description of what your product is all about. So there would be these 3 lines. The search platform's decision really is just a matter of choosing which sequence of 3-line ads to show. But all the ads were really the same. Now, fast forward about 10 years to where we are now, and these things have been evolving gradually, but the place we are now is much more complex than that. Ads can look very different. So there are all sorts of different extensions that ads can have. So ads can range in size from 3 lines to up to 15 or even 18 lines. Mm-hmm. Underneath those basic 3 lines of an ad, you might have things like star ratings. Users might be evaluating how good is this hotel, and you get information from that about that, maybe from Yelp or some other third party or something. And you decide that this is useful information for the user, so we want to show this along with the ad. Maybe there's going to be a phone number, maybe there's going to be an address, other kind of local information like that. There could be navigation links, and these actually really take up a lot of space. So maybe you put a series of 4 or 6 different links that would take you directly to different parts of the advertiser's homepage. Mm-hmm. And all these things make the ad bigger and bigger. So now the decision from the advertising platform's perspective is not just which advertisers' ads do we show, but which versions of which advertisers' ads do we show, given that we have constraints about how much advertising space we want to take up and maybe how many total ads we want to show.
That's interesting. Yeah, because I can have I can keep those old 3-line versions, or I could have maybe up to a 10-line, 11-line version. So the problem for the platform is maybe do I pick 2 large ads, 3 mediums, 4 smalls, or something along those lines? Is that what you describe as the ad packing problem?
Exactly, yeah. So, the way we kind of formalize it in this paper that we wrote is, we imagine that the search platform has a certain number of lines, maybe it's 15 or 18 lines, and as you said, you could conceivably fill, if you had one really great ad that was much better than all the others, then maybe you want to show the huge, maybe it's a 15-line version of that ad and just let that suck up all the attention. Or if you don't, maybe you'd rather show 5 small 3-line ads.
You identify that that's an NP-hard problem. I don't want to take for granted that listeners are familiar with enough computational theory to appreciate that, but in colloquial terms, could you describe how challenging it is a little bit for the ad platform to decide on the best possible configuration, or even what the best possible configuration is?
Sure. So the first thing to say is that even problems that aren't normally considered very computationally hard, in our environment, we have to be very attentive and sensitive to how much computational time we take, because the constraints that we're under are very severe. Because this auction has to take place in a matter of milliseconds. We've got to decide which ads to show and then render them on a web page along with all the other search results. You don't have even a full second or 2 seconds to run this whole auction. Maybe we have 3 ad slots that we want to fill up, but maybe there are 100 different advertisers who are all bidding in the auction for a given keyword. And maybe each one of those advertisers has 4 or 5 different versions of their ad. So now we're talking about several hundred different ad variants that are all competing. And we have to consider what is the optimal combination of 3 or less of these ads that fit within, say, 15 lines or whatever the constraint is. That world is very big. Combinatorially, we're in a space that's very large, especially if you have only a matter of tens of milliseconds to run the entire auction.
I almost have to sit back and repeat it to myself for it to sink in that basically every search I do online, which for me is dozens, if not maybe hundreds a day, every one of those presumably might be running an auction in the background, and I expect a very fast response time. I don't want to go, search and get a cup of coffee and come back. I need, as you say, milliseconds for all this to happen. So we definitely need something that isn't an exhaustive search, and I think that's maybe one of the core novel contributions of your most recent paper. Can you tell me a little bit about what you and your co-authors came up with?
So there are actually 2 parts to the auction, and both of them are kind of computationally challenging. So the first part is just which ads do we show? But that's not the end, right? Because then we have to figure out now what prices do we show for each of these ads. Now, in the old world, the way they handled this was, well, because we had ads that were all simple, the which ads do we show problem can be solved by just really sorting them, because we look at who has the highest bid and you're going to go at the top. If the goal is to try to show the ads that want to be shown most, which we may think tracks well with what the user would want to see most, then we can just sort them, put them on the page, and then we have this simple pricing scheme, as we said, that is just look at the bid of the guy below you, and that's your price. Okay, our world is now very different. We have all these different combinations. So what we came up with is to first basically come up with an estimate of how clickable is each ad, for lack of a better term. Some estimate that says, if we were to show this ad at the top, what do we think is the likelihood with which a user would want to click on it? And that's a good proxy for how interesting it is, but it also tells us exactly the circumstance under which we would get paid, because the search engine only gets paid for clicks, not just for showing an ad if they don't get clicked. So you can come up with a ranking of the ads, loosely in terms of what they're willing to pay times their probability of being clicked, assuming that they were shown at the top. And we start with a greedy outcome, which is basically just to rank them in terms of that product, bid times probability of click. And then we take the best ad, we put it in our provisional allocation. Then we go and look at the ads that are remaining, and we kick out all the other versions from that advertiser, right? Because we don't want to show more than one ad from the same advertiser. So we kick out those ads, and we kick out any ads that maybe wouldn't fit on the space we have available, given what we put in our provisional allocation already. So then we take the next remaining ad that fits, and so on and so forth until we fill up whatever space we have for ads. And that gives us kind of a starting point of an allocation. That might be very bad, or it might be good, but we definitely don't stop there. Then we start a procedure of local search. We basically look at all kind of one-for-one swaps. What if we were to take out this ad that's at the top and swap positions with any of the other ads that are in our provisional allocation, but also swap it with any ad that didn't get allocated in this first initial greedy allocation, and see if that yields an improvement. And we basically keep doing that until we can't improve the configuration of ads that we have any longer.
Makes sense. So it's kind of a greedy search and then an exploration phase. Is that a reasonable summary?
Yeah, that's right. And I mean, so we didn't know how well this would work. So we also implemented, the optimal, because although it's an NP complete problem for the numbers that we're talking about with a few hundred ads, maybe just a handful of slots up to say 5 slots at the top of the page, it's actually quite feasible for us to actually code up, a provably optimal version of this that's maybe a little bit better than brute force, just doing some intelligent pruning of the search space. It's good enough for testing. It's just not good enough to put online so that you don't have to go and get a cup of coffee while you wait for your search results. So it's not going to run in milliseconds. Maybe it'll run in tens of milliseconds or hundreds of milliseconds. So we have that to be able to compare as a baseline to see how well our fast local search approximation is doing. And we're able to demonstrate that we get 99.8% or whatever of the kind of the optimal, according to our metric, which is advertiser value. We get almost all of that advertiser value with our approximate algorithm that we use.
Yeah, that was one of the parts that I thought was really neat about your paper, that you're able to take as long as you want in testing mode, even though you can't run that close to brute force approach online. You can run it offline and compare. And there's 2 really neat metrics you guys describe. One, I think you've already described as your efficiency, but you make a distinction between the efficiency rate and the optimality rate. Could you go into the details there?
Sure, right. So there's kind of the percentage of time that our algorithm actually yields exactly the optimal allocation, the set of ads. And that's something that I don't have the numbers in front of me, but I think, for when you only have one or two or three slots at the top of the page, it's very high. It's like 95% or something. But as you have more slots, maybe you have 4 or 5 positions at the top, it goes down to only somewhere around 80%, which means 20% of the time we're not showing exactly what is optimal. So if you just look at that statistic, you might get worried and say, maybe we have to keep going. Maybe this local search or the version of local search that we implemented isn't good enough. But then we looked and saw, as you said, what is the efficiency rate? Maybe we're showing something that's not exactly the optimal allocation, but maybe it's like negligibly different. And that's what we found, that in many of these circumstances, maybe we've trimmed off one line of the last ad or something, but it basically doesn't matter, because in terms of the total, our objective function, which again is advertiser value minus an estimate that we have of cost to the user for their user experience, we're still at a rate of 99 point something % of that efficiency rate.
Yeah, that's really interesting. So if I don't know if it's the CEO's choice or some decision maker who owns these ad auction platforms, I've got maybe 2 options on the table. We could run this very slow, optimal brute force type approach. And I know that that's not possible because the response times would be massively too slow and maybe even the hardware cost to run that. Or I can adopt your solution that is pretty darn close to optimal in a lot of cases. But it does leave this open question of, is there a middle ground? Do you have any thoughts on an algorithm similar to yours that makes, a few improvements, maybe some dynamic programming or something that gets you a little bit more efficiency? Or can we put some asymptotic bounds on this?
Yeah, so actually, after we wrote the paper and kind of built our prototype and did all this testing, we kind of kept going with our version of this optimal algorithm and said, as you said, maybe we can do some tricks with memoization or whatever, dynamic programming to take us away from brute force. And it's still, we know because of the NP hardness result, fine, it's, asymptotically, it's still going to be worst case exponential running time. But that doesn't really matter here because we have a fixed limit on the number of ads we can show. So let's just keep working on this. And we did actually get to an optimal algorithm that would probably be feasible. But we kind of said, given how close we are to the efficiency rate, we're not sure that it really matters. So, we could write a follow-up paper telling about how we did that, but I'm not sure that anybody would really care because the local search approximation we have is so close to optimal anyway, and it's conceptually much simpler.
Interesting. Yeah, then you get into these debates of, well, maybe the other one would make a few more pennies on the dollar or something, but it's also a more complex system running in a production environment that people might have a harder time implementing or debugging.
Exactly. Yeah. I mean, for all the faults that I mentioned about, the old GSP and how it doesn't really fit well in this world of rich ads, we are kind of giving up something up if you were to adopt this new scheme, but by kind of embracing the complexity and dealing with it, you no longer have a search auction that you can describe very quickly. We have to go through this process of talking about first we have a greedy allocation, then the local swaps and all that. And we haven't even gotten into the pricing yet. So you do give something up. Going from old GSP to what we've got now, this local search version, the gains are big enough, perhaps, to make it worth it. But, the gains from 99 point whatever % to the optimal probably are not worth it, given, how many more thousands of lines of code or whatever it would be required. And just the opportunity for mistakes and for people without the facility or the experience with it to be able to get into that code and understand it probably adds some costs there.
Yeah. When you're doing your back testing and these sort of simulations, if you will, to calculate optimal versus the efficiency under your algorithm, you had mentioned that you're doing this based on advertiser value. Of course, every test you run is sort of a hypothetical. You don't know what click someone would have done had you ordered things differently or showed different ads. Can you talk a little bit about how you derive advertiser value and use that in your optimization?
Right. So, yeah. So that's a possible pitfall. Sometimes you might do something in simulation, and then once it actually gets tested, you get a result that's surprising. And this is one of the places where a surprise could crop up. In order to do simulation, we have to come up with a model of how likely users are to click based on counterfactuals. So if we, instead of putting ad A in position 1, starting on line 1, we start it on line 9, and it's the third slot, say, something like that, we have to extrapolate what we think the probability of click would be. We have a model, I think I mentioned before, that tells us what your probability of click would be if your ad were shown at the top. And so, we look at all the features of the ad and maybe the features of the user who's doing the search and how that interacts with the keyword that they enter. and we get that estimate. And then we have to extrapolate what would happen as we move your ad down the page. We basically apply a multiplier, kind of a curve that degrades that click probability. And it's it's a uniform thing applied to every ad that diminishes your probability as we move you down the page. And that's also estimated from data. So we look at how likely users are to click on lines 4, 5, and 6, say, of the advertising space compared to lines 1, 2, and 3, or an ad that's in 5, 6, and 7, et cetera. So we kind of aggregate all that data and come up with a curve that represents how fast the probability of click degrades as you move down the page. And that's how we're able to make inferences about, speculative inferences about what would happen if we were to show ads in a different configuration.
I actually have some experience in this space, and as users can quickly probably picture, there's that sort of almost like log normal drop-off of likelihood of click as the rank goes down. Of course, I'm using the word rank, which shows my age a little bit. I did all that work in an era when I was bidding on those 3-line ads, and rank 1 meant top position, rank 2 meant second position. But of course, you're describing in a world where there's more of a variance to it. It's less about the exact position, but more about the starting line. And maybe there are 3 ads above you or 1 large ad. Does that complication make your analysis trickier, or did that turn out to be trivial in the modeling phase?
It's something we had to change. So, the old model, going back for 10 years worth of research papers that were written about GSP, was that the click probability for an ad is the product of its inherent clickability plus property of the slot that it's shown in. And, we had to throw that out and say, well, if the second slot can start either on line 4 or line 17, that should make a big difference, right? I mean, if you're starting on line 4, you're going to be much more likely to be clicked than if you're starting on line 17. So we had to come up with kind of an expansion of this model. It still kind of retains part of the spirit of the old model in that there's this separation between this factor that's inherent to the ad and a factor that's inherent to your position on the page, but it's more specific or fine-grained because we're now looking at the actual location on the page rather than just the slot.
So in any auction mechanism, you have a couple of players. You have the advertiser who wants to get value. You have the owner of the auction platform that wants to earn revenue as well. And then, of course, hopefully people don't forget that we have users who don't want to be barraged with ads that are totally irrelevant and annoying. And it can seem difficult to balance all 3 of these priorities. I think you guys accomplished that with the constraints that are in your optimization. Can you describe that win-win-win type scenario that you arrive at?
The hope in all of this is that what might be happening prior to this work or this proposal that we're making is that you've got an ad that's very big, and it's just because it comes along with these site links that make it 15 lines, we're just going to show that because, well, the advertiser provided us with that. But if we're able to tell that those site links, maybe the bottom 10 lines of the ad, are just really not doing anything for the ad, they're not useful to the user at all, the user never clicks on that, they'd be just as well just seeing the first 3 or 4 or 5 lines, then showing those 10 lines is a bad thing. It's wasteful for everybody. It's bad for the search platform because it's just wasted space. We could be showing other ads that are more useful to the user. And for the same reason, it's bad for the user because you're sucking my attention into something that I have no interest in. I'd rather see either another ad that's of more interest, or probably even better from the user's perspective, I'd rather see those organic, real search results that are not paid higher up on the page so I can get to what I want quicker. But it's potentially even better for the advertiser too, because if you're an advertiser who's actually got something useful to the user and we can cut out those 10 lines from your competitor, then we can get your ad shown, whereas before we wouldn't have been able to show your ad, or you would have had to bid much higher in order to get your ad shown because we didn't realize that you had something that was kind of more useful than these extraneous, wasteful lines from your competitor.
So I'd love to talk a little bit on the multi-agent side of this and how we think about the different actors at play in the auction, and maybe start with a question that I guess is inherently philosophical, so just sort of your thoughts on this if you have any.
I love philosophy.
Oh, great. So when we talk about, these, I'll call it the Vickery auction, even though, as you've established, it's more complicated than that. But the Equilibria solution is to bid your true valuation. And we call it an Equilibria because from a game theory perspective, it means I have both myself and the other players have no incentive to leave that strategy, that if we all are playing this, the results turn out best for us. To arrive at that conclusion, one needs an understanding of game theory, which unfortunately not everyone has in the world. So from one perspective, you could say this is a criticism that we assume we have these perfectly rational agents with common knowledge of perfect rationality, which seems to not necessarily be the case. Or on the other hand, you could say that, well, maybe someone is very unintelligent actually, and they're bidding, in a way that is randomly, they're going to fall out of the auction because they're not going to be successful in the long run. You can't run your business efficiently if you just bid randomly. So only people that happen to, either because they're smart or because they fell into it, adopt the Equilibria strategy. They're the ones who are successful and continue to the future. Do you have any thoughts on how we arrive at equilibrias in practice?
Okay, yeah. So first of all, to clarify, with GSP, the equilibrium that exists is not even a truthful equilibrium. So, it's not even the case that, well, as long as everybody else is bidding truthful, you're best off being truthful. No, it's more extreme than that. It's something more like, if you know what all your competitors, there exists a profile of bids, such that if everybody knows that everybody else is bidding in a certain way, which again is not truthful, but they're just bidding some other specific thing, there exists this fixed point where nobody can benefit from deviating. So that point might, to an advertiser, seem completely arbitrary, because the bid that I'm supposed to bid in the equilibrium, it's not actually my value per click. It's this other thing that just happens to have this good property. And you can prove that equilibrium point exists. But I think you're right to be skeptical or questioning of whether advertisers would actually get into this fixed point. So I'm probably not the best person to try to defend it, because I'm not I'm also skeptical of it. But let me give you kind of the standard line that I've heard before, that
Sure.
that people sometimes comfort themselves with, and maybe it's right, maybe it's wrong, I don't know. But it's the idea is that this kind of auction is a little bit unique. It's not just like, well, there's like an auction at Christie's where there's a Picasso up for bid and everybody shows up and you're trying to think about what the other guys are bidding and maybe you have some idea, but you're largely guessing. No, this auction is happening repeatedly in vast quantities. So, maybe millions of times a day, these same competitors are competing with each other for the same keyword. Maybe, again, laptop, something very common like that. If that's searched for a million times in whatever time period, then there's a big opportunity to kind of learn and adapt to what your competitors are doing. So it might not be that they can explicitly work out through, doing the math or analyzing the formulas that this is my best bid. Actually, even no matter how much time they spent with the formulas, it wouldn't help them unless they were able to actually see what their competitors are doing anyway. So a necessary part of the story is you learn what your competitors are doing. But the vague intuition is that over time, they just kind of funneled into this point where they realize that I've tried a bunch of things in the kind of local space around what my equilibrium bid happens to be, and I found the optimum. So therefore, since I want to maximize my profit as an advertiser, I stick to that. And every advertiser is doing that. And it might not happen immediately, but after a little time, they adapt to each other and they fall into this equilibrium.
Yeah, I think that's a good description of a point of view that one might have. I'm certainly amenable to it, but it's something I'm always kind of thinking about.
Right. And I mean, it's one of the interesting things is it's kind of impossible for us to either confirm or disconfirm the conjecture that they are in that kind of an equilibrium. What we can observe potentially, if you had access to the data, the bidding data, you could see, well, are the bids stable, or are they kind of always flittering around? And if they look stable, you might say, well, they're in an equilibrium. But are they in the equilibrium that the actual rational equilibrium of GSP? To know that, you'd have to know each advertiser's value for a click, and that's something that's kind of inherently hidden to them. They can't tell us. They wouldn't tell us if we asked. So we'll never know about that, but we can at least see whether or not it's stable or not.
That's interesting. Do you think we could evaluate whether or not that's a Pareto optimal equilibria, or do we assume that people would fall into the global equilibria?
So GSP does, in theory, have many equilibria. There's the efficient one, and then there are others. And I think in order to figure out whether or not you were in the efficient one, you would have to have some information about the advertiser values. So without getting that, we really couldn't know.
Yeah.
So that just you can comfort yourself with is to say, there is this efficient equilibrium, and there are some results that say this equilibrium has some special properties that makes it a little bit unique. But you do have to contend with the fact that there are these competing equilibria. So if the star that's guiding you is this theory that you think, well, bidders end up in equilibria, then you do have to worry about the fact that you could end up in a bad one too.
Yeah, makes sense. So my own personal anecdotal experiences in being a web user and seeing a fair amount of ads is that with the diversity and richness of ads these days, some of the features you described, like star ratings and deep linking, it's time for some evolutions in the mechanisms that run the ads. And that way I was really glad to find your paper. I think it could be a good step towards reinventing some of these systems. I wanted to ask if your technique, your algorithm was rolled out. I mean, maybe the advertising platform would do a big press release and let everyone know, but it could also be rolled out quietly. Nothing in theory changes from the bidder's perspective. Do you think that there'd be a natural evolution of users recognizing that something has changed and adjusting, and would we kind of converge to a new steady state? Or would we, so in other words, I guess my question is, would we have to wait for the system to kind of rebalance? Would it rebalance at all, or would that happen right away?
So are you asking from the kind of the user web experience perspective or from the advertiser behavior perspective?
The advertiser behavior. Like, would I go and update my bids because I've observed something is different about the responses I'm getting?
Right. So that part of it, I think, is really dependent on what kind of pricing mechanism you pair this with. And we didn't talk about that at all. But, one of the things that we suggest in the paper is that we suggest a way of kind of porting the old GSP pricing mechanism to this more complex system in a way that retains what we consider to be the core spirit of what that old GSP pricing rule is. And that is, you can think of charging each bidder that wins, what is the minimum bid that they would have had to submit in order to get at least as good of an allocation. Now, as good of an allocation in our world, this more complex world, doesn't mean necessarily, as high of a slot, because it could be, well, if you increase your bid a little bit more, what happens is we actually move you down a position, but instead of showing the 3-line version of your ad, we show the 10-line version of your ad. So you could, so it's not as simple or uniform in this way, but nonetheless, you can still think about, if you imagine a graph where the x-axis is, what's your bid as an advertiser, holding everybody else's behavior fixed, and the y-axis is what's the probability of click that you get from your allocation. You'll draw a curve that's increasing. As you increase your bid, there are going to be a bunch of steps along that road. And, in the old world, those steps just correspond to your ad being, gradually climbing up the ranks from slot 5, say, to slot 4, 3, 2, 1. So maybe you'd have a few steps. Now we might have a lot more fine-grained steps as we add lines to your ad and shift its location around on the page, but we still have that curve. And you can still apply a pricing rule that says, well, we look at your bid and we think about what the kind of the minimum bid is that you would have had to do to end up on the step that you got to. That is your probability of click that you got from the bid that you submitted. And we kind of call that the core extension or application of the spirit of the GSP pricing rule to our environment. And now getting back to your question, if you were to implement that kind of a pricing rule, then I think for advertisers, the experience would remain pretty seamless. So I wouldn't expect them to feel like they had to adapt much at all. Hopefully that the actually what they would get is more efficiency. They note that they're getting more valuable clicks because we've figured out a way to not show their ad when it's in a more wasteful situation, or if show the big version of their ad that might cost more when those extra lines aren't doing anything for them.
Yeah, that makes sense. It ties in nicely with a comment you'd made earlier on that I think, and this is my phrasing of it, but a well-designed auction platform allows the advertiser to not be required to think more. That if they're, right. Which I think is incredibly important as the systems grow more pervasive and more complex. Lastly, I wanted to ask about the fact that this is an anytime algorithm. I think this is a fascinating label that you don't see that much in the literature, but I suspect it's going to become more and more prevalent as we have faster decision systems like online auctions that run at very high velocities. Could you describe what a anytime algorithm is and how your approach qualifies as one?
The way I think about an anytime algorithm, that it's an algorithm that could be stopped at any point in time and you still get a workable solution. But if you let it run longer and longer, then the solution you get could potentially get better and better and better. And our algorithm is like that because we do this first, we come up with this greedy allocation, but then we just go through this loop of improving it and improving it. And eventually this loop would end if we got to something optimal or something that's locally optimal. But if the clock runs out, if the engineers who are implementing this or whatever are told, you have a maximum of 20 milliseconds or whatever it might be to run your auction, when that clock runs out and we still haven't gotten to a local optimum, we can stop and we still know that we've gotten to a solution that's improved greatly over the greedy allocation that we started with, and it's on the way towards optimal, but it's maybe not quite all the way there. We can stop and use that. If the number of ad candidates that we have expands or the runtime constraints change and suddenly we get under much more pressure, we can still use this algorithm without things going wrong. And that kind of a principle is what we tried to apply in general to the design of this whole system. We tried to say, like, why are we doing this work? It's because the old GSP turned out to be kind of brittle as things changed. So we wanted to make this new approach not brittle, but rather more flexible so that, if next week a totally different kind of ad format starts to be popular, maybe they're showing pictures or some other weird stuff, we can just easily slot that into our system without having to start again from the ground up.
Yeah, makes sense. And in my read, it seems like you guys have really done a great job accomplishing that. I wanted to lastly ask, what's next for this line of work? Is this the conclusion of a big project, or are there some next steps coming?
It's the conclusion of the main chunk, but I think there are definitely dimensions of this that could stand to be improved. If I had to pick one, probably maybe the biggest one is the way that we make predictions about where and when the user will click. It's kind of a fairly simplistic model where we have this independence assumption where there are these two different factors, the factor that's associated with your ad, and there's a factor associated with where we show your ad on the page. But the way we've modeled it, we haven't taken into account at all the fact that maybe if you show two kinds of ads next to each other that are kind of similar, that might have an effect on the click probability for each ad that's different from if you show two totally different types of ads.
Has this been accepted into an upcoming conference that people should keep an eye out for?
Yeah, the paper associated with this work is going to appear in the World Wide Web conference in Australia in April. And I also want to mention that this is, I just happen to be the one talking about it, but this work is a collaboration with three other coworkers of mine, Prabhakar Krishnamurthy, Maxim Spiridenko, and Chris Wilkins.
Excellent. Well, I do have a surprisingly disproportionate by population number of Australian listeners, which I'm very happy to have on board. I don't know how I got them, but I'm glad they're there. Maybe someone will be in attendance. Can you give a few details about the conference if they want to come hear the presentation?
The conference is in Perth, and it's between April 3rd and April 7th, and I'll be there. Happy to be going to Australia for the first time, so I'd love to meet some of your listeners.
Excellent. Yeah, well, I hope if anyone hears you here, they'll come and say hello. Ruggiero, thank you so much for coming on and sharing your insight. I really enjoyed this paper. I hope listeners check it out as well.
It was my pleasure, Kyle. Thanks for talking to me.
Data Skeptic is a listener-supported program. To support the show, visit dataskeptic.com and click on the membership tab.